Hello everybody and welcome to section 4. After we know how to create 2D sketches and how to turn them into fully defined sketches, and after we know how to modify them, it's the time to talk about 3D modeling. We will start with what we call sketch-based features, and we will start with a very important tool, which is Extruded Boss. Let's create a new part. Since the name is sketch-based features, that means we need to create 2D sketches and later we can convert them into 3D bodies. The simplest example, if we have a circle here and this be 50, finish the sketch, click the scroll and hold and rotate the view. Now imagine if we give this circle a height. It will become a cylinder, and this is exactly what Extruded Boss feature does. So you need to make sure that the sketch is selected from here and then select Extruded Boss. Now we have this thickness, and here we have some options to talk about. Let's start with direction 1. So this is the direction of the extrude. This value is 10 millimeters, which is the depth. Let's change it to 50 and notice the difference. So basically, this value controls the height of the cylinder. Now, let's say you're not happy with this direction. You want to be the opposite, like somewhere here. In this case, simply you can select reverse direction. And notice that our circle is still here. And the extrude goes to the left or to the right. Now, what if I want 50 of this height to the left and another 50 to the right? In this case, instead of a blind, you can open this and select mid-plane. Now, our sketch is here, and we have 50 to the left and 50 to the right. Let's go back to blind, and let's say I want 100 millimeters to the left and I want 30 millimeters to the right. In this case, we call this direction 1 and we can define direction 2. And here, as you can see, we have one arrow here, which means 1, and we have 2 arrows here, which means 2. So instead of 10, I will define 30. Once you're done with this, hit OK. And here you have this cylinder. SolidWorks automatically lists your sketch under this feature, and it hides this sketch. Now select the sketch, and here you will find Show. Here we have the sketch, so we have 100 units here, and we have 30 units here. You can change this view, so you can see the location of the sketch. And you can hide this sketch once again. Now, you can modify this sketch, and everything will be modified with it. Remember that whenever you have many loops like this, SolidWorks fills the enclosed area between them. So here, this is the enclosed area between this circle and this one. So basically, we will have a cylinder, but we will have a hole inside. Let's see this. So once again, it fills the enclosed area, which is this area. As we earlier discussed, you need a flat surface to start the sketch. So it's not limited to these planes. Now I have this flat surface. I can select this face, and here select sketch. If you don't have a normal view to this face, simply select the sketch from here, and then normal too. Now, if I finish this sketch and I try to extrude this, I will have this shape. Once again, I just need a flat surface to start my sketch, so I can select this one. And now you can extrude this. We can modify this sketch by opening the last extrude feature. And let's say I want to add a square here. As you can see, using Extruded Boss is very easy and straightforward. You only need to have a closed sketch without any intersection. Later on, we will talk about some problems with this feature. Next, we will talk about Extruded Boss feature Part 2. Sketch Boss Part 2. We need to create this sketch. Basically, it's half a circle here, and a horizontal line, and its tangent, and it's coincident with the quadrant point, and the same one as here, and then you need to connect them, and finally you need to offset this inside with 10 millimeters, and taking into account these dimensions. It's very important to have this line as a construction geometry. Otherwise, it will cause you a problem with dealing with Extruded Boss. Now, once you're done with this sketch, finish it. Make sure to select it from here, then select Extruded Boss. And now I want to set this to mid-plane and this to 50. Now once you have this shape, we need to talk about more options inside Extruded Boss feature. Our first sketch was on the front, and now I need to pick a plane that is perpendicular to the front, so I will pick the right and make sure to select the same arrangement. So the right plane is here. Now start a sketch there and simply in the center draw a circle and give it a diameter of 30. Now make sure to have the sketch selected here, then select Extruded Boss. Now we need to talk about these options. First of all, reverse the direction, and here instead of a blind we have through all, and this will extrude this circle up to the last face you have in your drawing. As you can see, it goes up to here. Now if you select up to next, it will take it up to the first face it faces, which is this one. If you select up to vertex, now you can select any vertex. For example, if I select this one, so this will be taken up to here. We have up to surface. You can define this surface, for example, or this one. And notice how the shape of this circle takes this curve. So it takes the shape of the surface. Then we have offset from surface. Like I can say I want to extrude it up to here, but I don't want it to touch this face. I want an offset of 20 millimeters off it. But notice how it takes the shape of this face. Now, instead of having an offset this direction, we can reverse it, and here you have it. And now, if I finish the command, you can see that this face is not flat. It took the shape of this surface. We have some curve here. Now, I'll edit this feature once again. When we talk about multi-body technique in SolidWorks, we will talk about multi-body. So in addition to all of these, you still can define direction 2. and you still have all these options. In some occasions, you don't want to start on the face you sketched your drawing on. Like, I don't want to start here. In this case, you can go to From, and here we have some options. The default one is sketch plane, which is the plane we started the sketch on. Now, you have offset. So let's say I want to start 20 millimeters away from where I sketched that circle. So now it will start here. You can reverse this direction. So you will start at 20 millimeters away from this one. You can start here. And you can change this value. You have vertex. Let's say I want to start here. You can define a vertex. And then the extrude feature will start where you picked that vertex. It starts here and it goes up to here. You have face or surface or plane. Let's say I want to start with this surface. And here, the start of this extrude feature will be this face. It's not limited to curved faces. You can select flat one, like this one. And notice how you started your sketch here, but you have the flexibility to take it whatever you want inside your drawing. So, if you show this sketch, you can see that the sketch is here, but our extrude feature is here. And now, if I edit this feature once again, for direction 1, I will select offset from surface, and I will select this one, and reverse this, and keep it to 20, and see how you started a sketch here, but you ended up with an extrude feature started at this face and ended with some offset of this one. Notice the curve we have. Select the front, for example, or any other plane you want, and draw a corner rectangle. I'll make it a square, and don't worry about placing it. I only care about this dimension. Once you're done with this, extrude this feature and set it to 100 millimeters. Here we have this option, which is a draft. So instead of going straight, we can have a draft here. Once you select a draft, you need to define an angle. And notice how when I increase this angle, how the shape changes. So this is inward draft. You can reverse it. So this is a good time saver. Like, instead of using many features, you can finish the whole thing with this feature. And definitely, you can define direction 2, and you can define another draft there. And you can reverse the direction. Next, we will explore more options inside Extruded Boss feature when talking about Extruded Boss Part 3. Extruded Boss Part 3. In SolidWorks, you can hide and show items, or you can suppress them. Hiding them means they are still there, but you only can't see them. But when you suppress a feature, it's still there, but it has no effect, as if it's not there. So if I select this feature, then you will find suppress. Now, the icon is grayed out here, and that's why it has no effect. You can suppress the sketches too. And now this part is totally empty, and they have no effect here, but in case you want them once again, you just simply hit unsuppress. So for now, suppress all the features you already did. Let's talk more in detail about SolidWorks Extruded Boss feature. Let's start a sketch on the front. And here, I'll draw a midpoint line. And I'll give it a length of 100 millimeters. Then finish the sketch. And here, we have an open contour. This sketch is not closed, but still we can extrude it. Make sure to select it from here, then select Extruded Boss. Now, since this is an open contour, SolidWorks automatically activates this option, Thin feature. Here, this line was taken and given a width and a thickness. So, the thickness is 10 millimeters. Let's try to change it. Now it's 20. And as you can see, this is the direction of the thickness. The line we created is here. And now this is the direction of the thickness. Then we can still control the depth or the width of this body. If you drag this arrow, you can control it, or you can set it to blind, and here, let's say 200. Now, what applies here applies the same when it comes to the conditions. You have one direction, which means if we have this view, this is the line we created, and the thickness goes down. Then you can reverse this direction, or you have mid-plane. Now this side is 20 millimeters, and this one is 20 millimeters. And finally, you have two direction, which means you can define the thickness of this direction and the thickness of this one. So let's say the first one, I want it to be 20, and for the second one, I want it to be 30. So this is what happens when dealing with open contours. It's not limited to lines. Let's start another sketch on the front. And this time I want to draw a circle. And I want SolidWorks to treat this as an open contour or as a thin feature. When you select Extruded Boss, here, since this is a closed contour, thin feature is not activated. You can activate it manually. And here, we have this sketch, and this is the thickness, and you can define the height. When having a closed contour and treating it as a thin feature, you can close the sides. As you can see, we have open ends. Now, if I edit this feature, I have this option, Cap Ends. Once you select it, it will be closed from here. And you can define the cap thickness. Now, how can we tell that this part is empty from inside or not? You can select Section View, and here you can alternate between the planes. And for example, I selected the top plane, and then you can drag this. And here, as you can see, this cylinder is empty from inside. When you want to exit the section view, simply click here. Another solution is to change the view. So select Hidden Lines Visible, and now it's obvious that we have this hidden line, which means this is empty from inside. Now, I will suppress these two features and start a new sketch on the front. Now we have this circle and it's divided into 4 portions. What if I want to give this portion a specific height and I want a different height for this one and this one and this one? You can create 4 sketches and then you can extrude each one separately, but this is not practical. So now keep the sketch selected and then select Extruded Boss. Here, as you can see, since we have some intersection, SolidWorks doesn't recognize any of these contours to be extruded. But we have this option, Selected Contours. And here you can tell SolidWorks which contour you would like to extrude. So for example, if you move the mouse here, you will see the suggested contours. So if I'm interested in extruding this portion, I will simply select it here and then deal with it as we earlier did with Extruded Boss feature. So now I have this portion without these and then hit OK. Now let's say I want to use the same sketch once again. You need to open this, select the sketch, then extrude once again, and here I'll select this portion and let's say this time I want this to be 40. Once again select the sketch from here, or you can open this one and select it from here. And I want this to be 60. And once again so as you can see, we used the same sketch with 4 Extruded Boss features. Now let's talk about some problems that may face you when dealing with this feature. If we start a sketch, and here if I have some kind of a sketch like this, then select Extrude, and here you can select any of these contours, but if you select Thin Feature, you can extrude the whole thing, and you can, in this case, select any of these. So sometimes it's confusing, so that's why you always need to pay attention to this window here. You need to pick the right contours. And since I have selected Thin Feature, notice when you select this contour, it won't be filled from inside. It will be something like this. So for now, that's all what we need to know about Extruded Boss feature. Next, we will talk about Extruded Cut. Extruded Cut. Until now, we learned how to add material. Now, it's the time to talk about how to remove material. As you can see, we have a 100 mm cube, and the extrude is mid-plane. Now, we can't remove material using Extruded Cut. Before doing so, we need to have a sketch. For example, if we start a sketch on this face, we just need to click on this face, and here you will find sketch. Then, draw a circle, and give it a diameter of 50 mm. Finish the sketch, and now select Extruded Cut. Now we need to define direction 1, and we have all these options, and we already saw most of them when we talked about Extruded Boss. For now, for blind, you need to define a distance, for example 50, and here is the preview. Then we have through all, and this takes the cut through all the material we have. And then we have up to next, and this takes the cut up to the next surface, which is this surface in our case. Then we have up to vertex. For example, you can select this vertex. And we have up to surface, and I can select this surface, for example. Then we have offset from surface, and you can select, let's say, 10 mm offset, and you can select this face. And here, as you can see, we have it inside, and this offset is 10 mm. You can reverse this offset by selecting reverse offset, and it will be 10 mm outside this face. And then we have mid-plane, and this will take 5 millimeters up and 5 millimeters down. For now, let's select through all, and here we have this cut. Now let's sketch another circle, but this time on this face, and here I want you to change the view to hidden lines visible. So these are the hidden lines of the cylinder we just created. Now draw another circle, and let's set this diameter to 45 millimeters. Now finish the sketch, go back to shaded with edges, then select extruded cut, then from here select through all. Now we have another cut inside, and now let's explore some options we have inside this feature. As we saw in Extruded Boss, you can define direction 2. So if you have this cut, let's say in the mid plane, you can define direction 2 for the cut. And if you have a complicated sketch, you can select some partial contours of it using selected contours. Another nice option is from. We can select offset, and instead of starting the cut from this face, we can start, let's say, 25 millimeters away from it, and here you can flip this offset, and now we have 25 millimeter distance, then the cut starts. If you hit OK, you will see that we still have the cut here. I will set this to sketch plane once again, and here I have this option, flip side to cut. Now, if you imagine what will be cut during this operation, let's say some part will be cut here, and some part will be cut here. So basically, we will remove this material. Now, this option, flip side to cut, will keep the material we talked about and will remove everything else. If you select this option, then hit OK, then hit OK once again, and notice how this geometry should be the one we wanted to remove. By activating this option, which is flip side to cut, it does the opposite, which means it keeps what we should remove. Most of the options inside Extrude Cut are the same as Extruded Boss, like the controls, direction 2, and the draft. And here you can navigate between these options to select the starting point of your operation. Next, we will talk about Revolved Boss. Revolved Boss. After we talked about Extruded Boss and Extruded Cut, now it's the time to talk about Revolved Boss and Revolved Cut. To better imagine this tool, I will start a sketch on the front, and here I will draw a center line, and then I will draw a corner rectangle somewhere here. Now imagine if this rectangle rotates about this center line, and while rotating it will generate a material with every place it passes through. So this is what Revolved Boss feature does. You need to keep the sketch selected, then select Revolved Boss. And here, as you can see, this rectangle rotated about this center line, creating this geometry. So basically, we need axis of revolution, and we need a sketch. Now, obviously, this rotation is 360 degrees. You can change this value, and let's say I want it to be 90, and this is considered as direction 1. You can flip this direction, and you can select direction 2. So direction 1 goes from the rectangle up to here, and direction 2 will go from the rectangle up to the other way, like this. So for now, let's stick to direction 1, and here we have some options, up to vertex, up to surface, and offset from surface, then we have mid-plane. For now, let's see mid-plane, and here, as you can see, this value was divided by 2, so we have 45 degrees here, and we have 45 degrees here. I'll go back to blind, then hit OK, and now I'll start a sketch on the top. Now, simply, I will just extrude this and set it to mid-plane. And now, once again, I will select this sketch and I will select Revolved Boss. This will create another feature, because you can use this sketch many times with different features. Like, I can use it with Extruded Boss, or I can use it with a second Revolved Boss feature. So I will select the sketch once again, then select Revolved Boss. And here, instead of a blind, I will select up to surface. Then select this surface. And here, as you can see, it was extended up to this surface here. You can reverse the direction and it will be extended the other way. And then we have offset from surface, and you need to define the value of the offset. But notice how the end face takes the shape of this surface. Like, this surface is not flat, and you can tell that from this view. The same principle applies to revolved cut. Let's see this with an example. If I drag this line here, then start a new sketch on the front, and now I'll draw a circle and set this diameter to 100 millimeters. And now let me pick a midpoint line and draw such a line, then trim entities. And here, imagine what will happen if this half circle rotates about this line. It will form a sphere. So finish the sketch and select Revolved Boss. And here, for the axis of revolution, you need to select this line. Then make sure to have it at 360 degrees, then hit OK. And here we have this sphere. Now, let's start a sketch on the front. And we need a center line here. Make sure to have it vertical. And then let's draw another one. And here, draw a circle. And let's set this diameter to 20. And now I want you to imagine the following. Imagine this circle rotating about this center line while removing material while it moves. So keep the sketch selected, then select Revolved Cut. And now, since we have two center lines, SolidWorks cannot decide which one you want to use. So we need to tell the program which center line to use. So for the axis of revolution, select this line. And here, make sure to have it 360, then hit OK. And as you can see, everything was removed in the path of that circle around the center line we have here. Now, once again, start a new sketch on the front, and let's try to do the same. Now, the circle will rotate about this line, removing everything in its way. So select Revolve Cut, and for the axis of revolution, select this axis, then hit OK, and here we have this shape. Next, we will talk about Swept Boss Cut. Another important tool in solid modeling in SolidWorks is Swept Boss. The principle is easy and straightforward. We need to create a path, and then we need to create a profile. If I start a sketch on the front, and now I need to start a sketch on a plane that will be perpendicular to this line. And in this case, it will be the right plane. Now imagine this square moving along this path, and while moving it will generate some kind of geometry. And this is what Swift Boss tool does. Simply select Swift Boss, and here there are two selections to make. The first one is the profile, and you can tell that from the icon shape here. So for the profile, this square will be the profile. And then for the path, this sketch will be the path. Then hit OK. And now we have this geometry. So what happened is that that square moved along that path, creating this geometry. Now let's edit this feature. Now instead of selecting that square, we have this option to select a circular profile. So here you just need to define a diameter. So I will define a 25 mm diameter, then OK. Now instead of that square, we have a circular profile. Let's go back here. And now, once again, I will edit this feature, and I will go back to Sketch Profile, and I will open this menu, and I will select this sketch. Then hit OK. So what happened is that SolidWorks fills the enclosed area between this circle and this square. Now, once again, start a sketch on the front, and simply convert this edge and this one. And now, instead of adding material, I will remove some material. So instead of using Swift Boss, I will select Swift Cut. And here, I will select Circular Profile, and I will increase this to 15. Then hit OK. And here we have this cut. So simply, we need a profile and we need a path, and then we can create this feature. Later on in this course, we will go back to this feature and we will talk about it in more detail. Next, we will talk about plane creation. Plane creation. From mathematics, we know that in order to be able to form a plane, you need at least 3 points that don't lie on the same line. Here we have this cube. It's 100 mm cube. To form a plane, we can use this point, and this point, and this one. If we connect these points, we will have a plane. Or we can use this point with this line to form a plane, since this line, by definition, is the distance between these 2 points. Or we can offset this face and have another plane. To form a plane, we go to Reference Geometry, then Plane. As you can see here, we have to define 3 references to form a plane. The first case is selecting 3 points. So for the first reference, I will select this point here. And for the second reference, I will select this point here. And for the third one, I will select this one here. As you can see, I have a plane created and I have 3 references selected. If you hit OK, you will find the plane listed here in the model tree. And now you can use this plane to create sketches. As you can see, this cylinder is normal to this plane. And this is the advantage of creating planes. You can have planes with different angles. Now the other case, if we select Reference Geometry once again, we can select this line. And this time, instead of selecting 3 points, I will select this line. For the second reference, I will select this point here. And as you can see, I have another plane created. I will hide the first one, and here we have the second one. And we can also use it to create other features. Another important case of creating planes is offset. When you select plane, simply select any flat surface. For example, this one, and here you need to define an offset value. Let's say 100. And you can define the number of copies. Another way of creating planes is selecting this face, for example, and then select this edge. And here we have some relations, and instead of perpendicular, let's select at angle. And try to change this angle. So we have two references here, this face and this edge. So this face is our first reference, and then we have this edge. So this plane can rotate about this edge we select here, and you can define the value of this rotation. So let's set this to 230, and here we have another plane with an angle. Let's say we want to create a plane right in the middle of this cube. In this case, select this face, and then simply select this one, and SolidWorks will automatically select mid-plane. If we hit OK, here we have a plane right in the middle. Another way, select plane, and this time select this cylindrical surface. And then select this face. And here, as you can see, we have two relations. When you select a cylindrical surface, you only have tangent. So this plane is tangent to this cylindrical surface, and for the second reference, which is this face here, the plane is perpendicular. Now let's have another case. Before doing so, I will hide all these planes, and I will start a sketch on the top. And simply draw a circle here and let it be 50 millimeters diameter, and set this distance to 200. And now extrude this to 100, then hit OK. And now select reference geometry. Select the cylinder for the first reference, and we have tangent here, and for the second reference I will select this one. So now it's perpendicular, you can select parallel, and in this case we have two conditions to achieve. The first one is that this new plane is tangent to the cylindrical surface, and the second one is that it's parallel to this surface. So the two conditions are achieved. Now let's edit this feature once again, and instead of parallel, let's select perpendicular. And here it's tangent to the cylindrical surface, and at the same time it's perpendicular to this one. Once again, edit this feature, and look at the direction of the tangency. What if I want it to be tangent, but not on this direction? I want it to be somewhere here. In this case, the only thing you need to do is to select this option, flip offset. And here we have it on the other side. Now, let's talk about other cases. So I will select this plane, hold Shift, and select the first extrude, and then select suppress. Now, let me show these planes. And here I have the three planes we already know. Now select reference geometry, plane, and this time select the front and select the top. And here, as you can see, you have a plane in between and it has some angle, like 45 degrees angle, because we already selected two perpendicular planes. So once you select two planes or two faces, the resulting plane will be right in the middle between them. Another important reference geometry to create is axis. Select axis, and here we have many options. For now, let's talk about two planes. So the intersection of any two planes forms an axis. For example, if I select the front and the top, then hit OK, and here you have axis 1. If you hide all these planes, you can see that we have axis 1. If I unsuppress this feature and select axis, here you have this option, one line, edge, axis. So select this edge, and here you will have a new axis. Later on in this course, we will see when we need to create axis. Next, we will talk about multi-body technique. Multi-body technique. Here in SolidWorks, we have a very important concept which is called multi-body technique. To understand this technique, let's start with a sketch on the front. Draw the same sketch and once done, extrude this to 100. And here, hit OK. Now, if we have a look at the model tree here, you can see that we have solid bodies and we have number 2. If we open this folder, you will find one body, two bodies, which means we already created a part file, but inside this part we have two bodies. That's why I can deal with this separately and I can deal with this separately. And this will be better understood when it comes to assembly design. For now, we need to know that in this case we have two bodies, not one, and we can treat each one separately, and we can even extract them separately. The reason why we have two bodies here is that these two cylinders are not connected, and that's why SolidWorks understands that they must be separated. Now, I will start a sketch on this face, and simply I will start with a corner rectangle, snap to the quadrant point, and snap to the quadrant point here. Without making it a fully defined sketch, just exit the sketch and select Extruded Boss and set this to 10 mm. Now, as you can see, I have a new option, Merge Results. Keep it selected, then hit OK, and notice what happened here. I only have one body. The new Extruded Boss I created connected these bodies, so SolidWorks now gives you the option to have one body or to have three bodies. If you would like to have three bodies, you can edit this feature, and here we have Merge Result. You can deselect this option, then hit OK, and if you have a look here, now we have three bodies, 1, 2, and 3. Now the advantage of that, imagine if we have a complex geometry. So if you want to extract one body of this geometry, simply you select it from here, then you have this option, insert into new part, you define the name, then hit OK, and here hit save. And as you can see, now we can deal with this body separately, so we don't need to deal with the whole part. And this part will be always connected to the original one. If I go back to the original model, I'll make some modification here, and I will show you what will happen on that part. Now, this is the same body I just extracted. If I go back to the extracted one, you will find the hole here, which means they are connected. So this option is very important, where you can merge the results or select not to merge them. There's a case where I want to merge this new Extruded Boss with this cylinder, for example, not with this one. In this case, select Merge Result, and here for Feature Scope, remove Auto Select, and select this one. Now what will happen is that this new body will be merged only with this one. And here, as you can see, I have two bodies. This is the first one, and this is the second one. This technique is very useful, and we will see it later in this course when we talk about assembly design, and then we will be able to compare it with the assembly design approach. Next, we will talk about linear pattern. Linear pattern. When we talk about linear pattern, we can divide it into two parts. The first one is patterning bodies, and the second one is patterning features. Let's start with patterning features. I'll start a new sketch here and draw a circle and set the following dimensions. Finish the sketch and make sure to keep the sketch selected, then select Extruded Cut. And here, select Through All. So what happened is that here, I have two features. This is the first one, and this is the second one. In this case, I would like to pattern this feature, the Extruded Cut. So, select Linear Pattern, and here, to pattern a feature, you need to define the direction, and then you need to define the feature itself. So for direction 1, you can use planes, you can use edges. If you select a plane, then the direction will be normal to it. So if I select this face, or if I select, let's say, the right plane, then the direction will be normal to it. So since we have it here, then the direction will be this way. So for now, I will select the right plane. For direction 2, let's keep it for now. And here, we need to define the feature. You can define the feature from here, or simply you can select this feature. Now, we have this option, spacing and instances. So, I need the spacing between the instances to be 50 millimeters, and you need to define the number of instances, and I want it to be 9 or even 10. It will go outside this plate, so let's keep it to 9. So basically, we defined the direction, we defined the feature, we defined the distance between the feature, and finally, we defined the number of features. Then hit OK. And here we have this whole repeated. Now, let's explore some options inside the feature itself. Now you can pattern on this side too. So for direction 2, you can select the top plane, or simply you can select this edge. And you need to define the spacing value, and let it be 50. And the number here should be 4. As you can see, we have everything here repeated in this direction. If you want to pattern only the original feature, which is only this cut, you can select Pattern Seed Only. And here you will have only the original feature patterned. When activating this option, you will have only this shape. Now once again, I will set this to 1 and I'll set this to 5, and I will increase the distance between them. If you go down, you find this option, instances to skip. For example, if I don't want this one to appear, I can simply select this point, and here you won't have it anymore. You can clear the selection, and here you'll have it once again. A very nice option here is instances to vary. For example, if I want to vary the diameter of this hole, I can simply select this dimension here, and as you can see, it's listed here. Now the value is 35 millimeters, and let's say I want to keep increasing this with 5 millimeters with each instance. So double click here and hit OK. And obviously, with each one, you will have a bigger hole. Now it can be the opposite, and in this case, you simply type in -5 and hit OK. And here the holes get smaller. Now once again, let's select direction 2. Remove this option and increase this number. Now we have this window here for direction 2, and we have the space increment. Here in this direction, the spacing is 50, as we indicated here. Now in this direction, the spacing is 60 millimeters, and let's say I want an increment with this value, and I want it to be, let's say, 10 millimeters. Or to make it more obvious, let's make it 30, and then hit OK. And here, as you can see, we have an increment in the spacing itself. Notice that we only have one body here, and that's why we patterned a feature itself. We didn't pattern bodies. Now the other case is patterning bodies. So SolidWorks, it treats this plate with the holes inside as one body, as you can see. So let's select linear pattern again, and for direction 1, let's select the right plane, and here, instead of features and faces, I will select bodies, and I want to pattern this body. The same options here. Let's set this to 300, or even we need it to be 600, and the number, let it be 5. The difference here is that we don't have this option anymore, instances to vary, because each copy of this will be treated as a single body. You can skip instances by selecting this option and select any instance you want to skip. And here, if you notice, we have 5 bodies. Now once again, you can select direction 2, and for example, I'll select this edge, and I will increase the number to 5, and I will set this to 300. And here I have 25 bodies, 5 by 5. So this is the difference between patterning features and patterning bodies. Next, we will talk about circular pattern. Circular pattern. The second type of patterns we will talk about is circular pattern. Let's start with a sketch on the front. And then let's extrude this circle. And let's show these planes. Let's say now we want to pattern this cylinder and we want it to form a shape something like this, and we should have an axis here so this cylinder can rotate about. Select this plane and notice how we can drag this, so you can better imagine the situation. Now the intersection between these two planes will form an axis here, but we still don't have that axis. So select reference geometry, then axis, and here select two planes, and then select this plane and this one. And here we have this axis. Now select circular pattern, and here we almost have the same options. Now select circular pattern, and it's almost the same as we did in linear pattern. The first thing, we need to define the direction. So in this case, the direction will be this axis, which means the cylinder will rotate about this axis. Here we need to define the angle, and we need to define the number of instances, and we will get back to this. Now this is the critical part. Here we have two options. The first one is to define features, and the second one is to define bodies. In this case, we need to define bodies, and we need to select this body. I will set this angle to 360, and the distribution will be over 360 degrees. I can control the number of instances, so I will set this to 10, and I will set the angle to 270, for example. And we have instances to skip, which means you can eliminate any of these instances. For example, if we are not interested in seeing this one, we can simply select it, and when we finish the command, we will not see it in the 3D space. Now, hit OK. And here we have these bodies. If we have a look here, as you can see, we have 9 bodies now. Let me show you what will happen if we try to pattern a feature. In this case, we will have an error message. I will delete this one, and this time I will select features, and I will select this one. You can see the preview here, but it will give an error message now. And the reason why we have an error message is that these bodies will not be connected. So how can SolidWorks see them as one body? If we have a base here and they are connected to it, then there is no problem in patterning a feature. But now, if we pattern a feature like this, nothing will hold it, or nothing will connect it to the other features, and that's why you will have 9 features not connected, and in the end, they will form one body, which is impossible. To solve this problem, let's start a sketch here. And let's draw a circle. And we will extrude it with this direction, let's say 10, and make sure to select Merge Result. Now, let's select Circular Pattern, and for direction 1, select this axis, and this time, for features, select this one. I will keep everything the same here, then hit OK. And here we still have one solid body, and we patterned these features. So it's very important to understand the multi-body concept in SolidWorks so you can deal with these features. Next, we will talk about mirror and other patterns. Mirror and other patterns. Let's start with a sketch on the front. And then let's draw a corner rectangle. Make it 50 millimeters away from the origin. And set the following dimensions. And then extrude it to 30 millimeters. And after that, let's show the right plane. As we saw in 2D sketching, we can mirror sketch entities about a line. The situation is almost the same when it comes to 3D modeling, but the only difference here is that we need a plane to mirror entities or bodies about. So instead of a line, we need a plane here. To mirror bodies or features, select Mirror, and then we need to define two things. The first one is the mirror face or plane. So in our case, it will be the right plane, and the situation is the same as pattern when it comes to body and feature. In this case, we need to mirror a body, and here we select this body. Then we have this preview, and here you have this option, Merge Solids. Since these two bodies are not connected with any geometry, we need to remove this option so we don't have an error message. If we keep it selected, then we will have this message. Fail to merge the newly generated body with the workpiece, because there's no connection between them. That's why we need to remove this option, then hit OK. And here, as you can see, now we have two bodies. Now, let me show you something different. If I drag this, then I won't have this mirror here anymore, and select Mirror once again. You can select any of these faces as the mirroring plane. So for the mirror face or plane, I will select this one this time, and here you can select this body. Now, let's see the case when we have this option activated, Merge Solids, then hit OK. And here we have one body because both of them were merged together. Now, if I deselect this option, you will have two bodies. So that's why this option is very important. Now, drag this here and select Mirror once again. Select this face. And this time, let's select Features. And I will select this Extrude. And then hit OK. And then we have only one body because we mirrored a feature, not a solid body. So for now, that's what we need to know about mirror. Another type of pattern is curve-driven pattern. Obviously, from the name, we need to have a curve. So let's start with a sketch on the front. And let's start with a 3-point arc and draw something like this. Here we need this arc to be tangent to this edge, and let's define some dimensions. So this will be 600, and you can define a horizontal distance here, and let it be 500. Now once we have this curve, we can select curve-driven pattern, and for direction 1 this time we need to select the curve itself. So I'll select this curve, and instead of features I will select bodies, and I will select this body. And here you have two options. The first one is to define the spacing, so you can define any value you want here. Or alternatively, we can select equal spacing, and we can define a number of instances. If we have this view, you can see that we have 5, 6, 7. Let's go back to 5, and here, as you can see, the new instances are not tangent to the curve. So you can select from alignment method, tangent to curve, and even though they don't lie on the curve itself, but you can tell that they are tangent to it. Then let's go back to align to seed, then hit OK. And here I want to point to that you can use lines, not only curves, but it makes more sense to use curves, otherwise you can select linear pattern. The last type of pattern we will talk about is sketch-driven pattern. Here you need to define some points, and then you can pattern a body. So if I select the front and start a sketch, and here select point, you can define as many points as you want, and you can define some dimensions to relate them to each other. But for now, we will only place some points like this, then hit OK. And here, select Sketch Driven Pattern. As you can see, the sketch was automatically selected. If not, you can simply select it from here. And then for bodies, I will select this one. And as you can see, whenever you have a point, you will have a body. Now, you can include more bodies, but this will be messy. Now, it's obvious that the alignment here is centroid, which means this point lies in the centroid of this body. Now, we have another alignment, which is selected point. So select selected point, and here you need to define a point to align the bodies with the sketch points. So for me, I will select this one. And here, as you can see, for the new bodies, this point was selected. Next, we will talk about rib. Rib feature. Let's create this sketch on the front, for example. This side is 100 and this side is 100. And this offset is 10 millimeters. And as you can see, the sketch is closed. Now, finish the sketch and then select Extruded Boss. And here, select Midplane and set this to 50 millimeters. Then hit OK. In some occasions, you will need to create a supporting item here, so you can support this body. Imagine if you have some kind of loading acting on this edge on this direction here, then you will need something to support this side. And for such a case, we use this tool, which is called rib. So select rib. So basically, we will create a sketch, and then later it will be converted to this rib. So we have two options. The first one is to create the sketch inside the rib feature, and the second one is to create the sketch outside the rib feature, then to define it as a rib. For now, let's select this face, normal to, and I will draw something like this. Only a line. This is 20. And this is 20. Now finish the sketch, and as you can see, you don't need to close it. And here you will have the suggested rib. We have three options for the thickness. As you can see, this is our line, and we have some material to the right and we have some material to the left. And the reason why is that the option here is set to both sides. If you select second side, it will take the whole thing to the right, and this is correct in our case. If you select first side, it will take the whole thing to the left, which is not correct because there will be no supporting material here. So let's stick to this option. And for the extrusion direction is correct, and you can tell that from the direction of this arrow, which means this space will be filled with the feature now. You can define a width. And in this case, I will set it to 5 millimeters, then hit OK. And here we have the rib created. Now, I will move this line here, and I will start a sketch on the front. And this time, I will snap to this point, and I will snap to this one. Or, instead of sticking to lines, this time I will draw an arc. Something like this. You don't need to define dimensions. Just finish the sketch, make sure it's selected, then select rib. And here, I need to increase this thickness to 10 millimeters, and we can change the orientation. And here, the direction is not correct in this way, it should be this way. And here, you can create this feature. So the shape is not limited to straight lines. Now, if you remember, we talked about a draft inside Extruded Boss feature, and here you can add some draft too. So we have this option, draft outward, and then you can increase the angle. And now let's see the result. And obviously we have this draft. More than that, you can have multi-segmented draft, which means if I drag this here, and let's start another sketch on the front, if I draw something like this, and then select Rib, keep the options the same, then hit OK. And here you can create it. And now let's see how we can create multi-segmented draft. So select a draft, and let's increase this to 4, then hit OK. And here we have this draft. So this is the first type of a draft. We have another type which is used in plastic industry mainly. So let's start with a sketch on the top. And here let's select center point straight slot. Create a slot with the following dimensions. And now select offset entities. Make sure to select chain, offset everything, and then let's extrude this to 50. And we need to close the base, so select this face, start a sketch, and then select center point straight slot, start here, draw something close to this, and then select this arc, hold Control, select this one, and then make radial. Finish the sketch, extrude this to 10 millimeters. Make sure the direction is downward, then hit OK. Maybe you saw this before in plastic parts. When you have something like this, you need to strengthen it from inside, so you have some parts here and here and here and so on. So let's see this case. Let's start a sketch. And now I will pick midpoint line, snap to the origin point and draw a line. Make sure to snap to this point here. And once again, select another midpoint line, draw another one, and another one here. Now, let me set this angle to 30, and draw another one, or simply select mirror, then select this line, and mirror it about this line. Finally, draw a circle here, and set this diameter to 45, and then select the trim entities and trim everything inside. Don't worry about fully defining this sketch for now. After finishing this, select Rep, and then set this to 5, and here the direction is correct, and then hit OK. So basically, we only created lines, and here we have the result. Notice how SolidWorks predicts the relation we have here, so it's smooth and tangent to this face. Now, let's edit this feature. Now we have this option, selected contours, so basically, you can select contours, then hit OK, and here we only have these contours. So here are the two cases where is Rep useful and you can use it. Next, we will talk about shell feature. Shell feature. Let's start with a sketch on the front, and simply let's draw this profile. And then let's extrude it with 100 millimeters and make it mid-plane. Now, instead of using extrude cut all the time, we have this nice tool which is called shell. You can select faces you want to remove, and then you can make this body empty from inside. For example, if I will remove this face, Then I need to define a thickness of the resulting body. For example, let it be 5 millimeters. Then hit OK. And here's the result. As you can see, now it's empty from inside, and the selected face was removed. Now, this thickness is 5 millimeters. Now let's go back and edit this feature. You can also remove more than one face. For example, if I want to remove this one in addition to this one, hit OK. And here, both faces were removed. As you can see, you can select as many faces as you want. This tool is very useful and a good time saver. Imagine if you need to do the following. Imagine how many Extruded Boss feature you need, or how many extruded cut features you need so you can create this model. But using shell, you only need one Extruded Boss feature and the shell feature. And then this geometry is created. Now, it's very important to know how to use this feature when having multi-body. Now, I will remove Merge Result, and here I have two bodies. So when I use shell for this one, it works only for this body. I still have this body, and I still have this one. So here you can select shell once again, and you can shell this body. So SolidWorks recognizes that this is a separate body, and that's why you can use shell feature with it separately. Next, we will talk about draft feature. Draft feature. Before we start, create a 100 mm cube. The draft feature is very important, especially for people who work in plastic industry. To create a draft, select Draft from the ribbon. Before we start, make sure that Manual is selected. We will talk about two types of a draft: neutral plane and parting line. Let's start with neutral plane. Think about it as the plane that will remain the same after drafting this part. For example, if I want to increase the size of the base of this one, but I want to keep this face the same, in this case, this face will be my neutral plane. And then you need to define the angle of the draft, and in this case, let's say 10 degrees, and faces to draft, so I want to draft these faces. Now what will happen is that this face will remain constant, and these four faces will be drafted outward. And how we define if they will be drafted outward or inward, it depends on this arrow here. This is the pull direction. So imagine if you pull this way, then the base will become bigger. And the opposite is true. If you push downwards, then the base will become smaller. It will be clear when we finish the command. So now, let's review it quickly. This is the neutral plane, the pull direction is this way, and we want to draft these four faces. The draft angle is 10, so we expect this base to become bigger. As you can see, the four faces were drafted with 10 degrees. Now, let's reverse this direction, and here is the result. It's not necessary to select all the faces. For example, if I'm interested in drafting two faces, this one and this one, then you will have them drafted, and the non-selected ones remain the same. So this is the first type of a draft. Before we proceed, let's start a sketch on this face, and here snap to the midpoint, and then define a distance here, and let it be 25. and make sure that this line is fully defined. Then finish the sketch. Click anywhere in the screen. Now, the aim of this line is to create a parting line on this body, so we can tell SolidWorks which part of this body we want to draft, like the upper one or the lower one. Before going to draft, we need to prepare it for drafting, so we need to use this tool, Split Line. This tool is very easy. We need to select the sketch, and for the faces, we need to select these faces. And now make sure to select projection and hit OK. And as you can see, this body was divided into two parts. To be more accurate, it's still one body, but now SolidWorks can see this upper part of it and can see this lower part of it. Now select draft once again, and this time select parting line. And for the direction of pull, let's select this face, and for the parting line, we need to select these 4 lines. Now set the angle to 15, then hit OK. And as you can see, the upper part was drafted. You can reverse the direction here, and it will be drafted outwards. Now, what if we want to draft the lower part of it? Simply edit this feature, select this line, hold Shift, and select the first one, and then select other face. Now hit OK. And as you can see, the lower part was drafted. Once again, if you want to draft it outwards, we simply flip this direction. So this is how we use a draft tool. We saw 2 cases. The first one is to draft based on the neutral plane, and the second one is drafting based on parting line. Next, we will talk about fillet and chamfer. Fillet and chamfer. When we talked about 2D sketching, we saw fillet and chamfer in 2D. Now, we will talk about fillet and chamfer in 3D. We have this cube. It's a 100 mm cube, and now we will fillet and chamfer some of these edges. Let's start with fillet. You can select it from here, and then we have many types of fillet, as you can see. The most important parameter to define here is the radius of the fillet. In this case, I will use 15. The first type is constant size fillet. Simply, you need to select an edge, and here you can see that we have this preview. You can select multiple edges, and you can deselect any of these edges, or you can delete or deselect any of them from this field here. And instead of selecting edges, you can select faces. So if I select this face, all these edges will be selected, and so on. Now hit OK, and here we have this fillet. Now I will edit this feature, and I will clear the selections, and only I will select this one. And here I have this small menu which suggests some selections. So for example, the first one is connected to start face, so we have 3 edges. So it will be this edge, this one, and this one, and this one. The other option is internal to feature, which means all the edges will be selected. So this is a faster way of selecting the edges. Now let's talk about another type of fillet. Select fillet once again, and here the second type is variable size fillet. You need to select an edge, and here we have V1 and V2, which means we will start with some radius and we will end with another one, which means the radius in between will vary between the 2 values you enter. For example, I will start with 5 millimeters. So for V1, I will set this to 5, and for V2, I will set this to 20. And here we have this preview, and as you can see, the fillet varies between these two values. Now, let's show the result. And we have some options to talk about. We have smooth transition, which is the case we already saw, and we have straight transition. And here, you can see that it goes with a straight line. To better control it, you can increase the number of instances. So select variable and then select this edge. And here, if you go down, you will find number of instances. You can increase it, and this will give you more accurate result. In this case, I will start with 0, and I will end up with 20. And I need straight transition. Here's the result. And let's see the case when we have a smooth transition. So this is the second type of fillet. Now I will suppress all of these. Let's talk about another type, and in this case it's face fillet. It's not that different from the first one. The only difference here is that you only select faces. So for the first face I will select this one, and for the second face I will select this one. Then you can define the value of the radius. The last type, which is full round fillet, and this is really useful in many occasions. Like, imagine if you want a fillet starts here and ends here, and the place of the fillet will be in this area. To do so, you need to select three faces: the start face, the middle face, and the end face. And here, the radius will be automatically calculated. So that's what we need to know about fillet. Now, let's talk about chamfer. It's almost the same principle. You need to select an edge. And here, as we did in the 2D sketching, you need to define the distance and the angle. You can change them, and you can see the update on the preview here. We have many options here. Instead of defining a distance and an angle, you can define two distances. And here, we only have one distance because it's symmetric. You can change this, and here you can enter the two values you have. Let's go back to the first option, and you can choose many edges together. Or simply, you can select this face, and you will have all the corners chamfered. It's easy and straightforward. Now, let me suppress this feature, and there's a very nice option inside chamfer, which is corner chamfer. You can find it here, vertex, and simply select a vertex, and you need to define three distances: distance 1, 2, 3. So for distance 1, you can increase it from here, and you can see the preview. And for distance 2, and for distance 3. And hit OK. And this is how we define vertex chamfer. Next, we will talk about 3D sketching. 3D sketch. In some occasions, we will need to create a sketch that goes through many planes, not only one. And these planes are not necessary to be parallel all the time. We have this tool in SolidWorks under Sketch tab. If you open this menu here, you will find 3D sketch. Now, there's no need to define a plane to start with. Simply, you will start your sketch in the 3D space. Let's start with the simplest and the most important command, line. Pick a line and snap to the origin here. Now, once you move the mouse, you can snap to the XY plane. or you can snap to this plane, or simply keep your eye here and you can tell which axis you are following. So in this case, I'm following the x-axis, and here I'm following the y-axis, and if I want to go to the z-axis, I need to hit the tab button, and now you can snap to the z-axis. So to change the plane, you just need to hit the tab key and it will take you to the next plane. Here, as you can see, I can snap to the x-axis and I can snap to the z-axis, which means I'm on the xz plane. Now, if I want to move to this plane here, which contains the y, I need to hit the tab button, and then I have this. And then I can snap to the y. Let's start creating a sketch. We'll start with the x-axis, and here I will define a length. And now let's proceed. Now I'm following the y, and then I need to follow the z. I follow the y again, and here I will hit the tab button to follow the x, and I need to go to the z once again, so I hit the tab button. I need to go to the y, and finally I will just connect these. As you can see, this sketch goes through many planes. Now I will set these to be equal, and I will set this to 60, and I want this one with this one to be equal, and this length should be 150. As you can see, you can apply all the relations we already talked about. You can apply fillet and chamfers. For example, here's a fillet. You can define the radius here, then hit OK. And here we have this fillet, and you can define chamfer. A 3D sketch is not limited to lines. You can use circles, arcs, rectangles. Some options are not active here, like polygon, slots, and ellipses. But you still can use all these commands. Now let's create a new sketch and let's see how we can use 3D sketching with a sweep, for example. So finish this sketch, select 3D sketch once again, start with a line, follow the x-axis, and then let's define a length. This is 1000. I need 100. And now pick a 3-point arc, snap to this point, and draw an arc, and make sure you are on the y-x plane. Now make sure it's tangent here, and let's give it a radius of 50. And once again, draw a line, make these tangent, and set this to 150. And now, once again, select 3-point arc, start here, but this time I need to change the plane, so hit the tab button, and draw something like this. As you can see now, I'm on another plane, which is the y-z plane. Set these to be tangent, and draw the following. Now I want these 2 points to lie along the z-axis. That's why select this point and select this point, and here you will find Make Along Z. After that, define a distance here and another one here. Finish the sketch, and as you can see, our sketch goes in 2 planes. Now keep the sketch selected, and from Features, let's select Swept Boss. And here, let's select Circular Profile, and I need this to be 30 millimeters. Then hit OK. And here we have this Swept Boss. So 3D sketching is very important, and it saves a lot of time when you try to create such a thing. In this case, you don't need to create many sketches, then to connect them to be able to create this Swept Boss. You only need to create one sketch, and you can go through as many planes as you want. Next, we will talk about Hole Wizard. Hole Wizard. We can create holes using Extruded Cut, but to be more professional, we need to create holes using Hole Wizard, a specified tool in SolidWorks for this purpose. It has many types of holes inside. In the advanced level of SolidWorks, when it comes to finite element analysis, SolidWorks recognizes holes created using this wizard better than it does with the extruded cut holes. So it has some kind of a special treatment in finite element analysis, and when we talk about detailed drawing, we will see that how we can easily detail these holes, and it's more efficient to detail holes created using Hole Wizard than detailing holes created using Extruded Cut. To create a hole using the Hole Wizard, you need to define 2 things: the type of the hole and the location of the hole. So select Hole Wizard, and here under the Type menu you can see we have the hole type, and we have these types: counterbore, countersink. You have just a hole, which is very close to a hole created using Extruded Cut. We have a straight tab, taper tab, and so on. And then you need to define the standard, and as you can see, we have all the well-known standards here. Then you define the type once again, and the size, the fit, and the end condition. We will go through them one by one. For now, let's create a countersink. Once you selected countersink, now you need to define the standard. I will go with the DIN, and here you need to define the type. I will go with this type, hexagonal socket, and then you need to define the size of the hole. So I will go with M20, and here you need to define the fit. There are 3 classifications of the fit: normal, which is not too loose and not too fit, and we have loose and close. So I will go with the normal one, and here's the end condition. If you have a specific depth to this hole, you can define it here, like blind, or you can select through all, up to next, up to vertex, up to surface, and we already saw all these options when we talked about Extruded Boss. So I will stick to through all, and here we are done of defining the countersink. Now we need to define the positions. For positions, you can see here, we need to define a point, and the countersink will be installed there. So basically, we are creating a 3D sketch here. So select 3D sketch, and as you can see, point was automatically selected. You need only to place points, and whenever you place a point, then a hole will be placed. So if you place a point here and a point here, then you need to define some dimensions. So I will set this to 30 and this to 30, and for example you can have a distance here and another one here. If you're happy with the locations of these, then go back to the type, and here you can see the end condition. I have through all, and that's why they go up to here. You have up to next, up to vertex. If you select blind, you need to set the value manually. Then hit OK. And as you can see, they were created. So this is how we define and create holes in SolidWorks. Later on, you will see the advantage of this method when we talk about detailing and creating 2D shop drawing. Next, we will talk about Extruded Boss. Extruded Boss. For simplicity, we will call this command loft. This command is used to create complex geometry. Basically, we draw some sketches and we connect them using this command. Before we start, we need to create another plane. So select reference geometry plane, then select the top and set this distance to 100. So basically, I just offsetted the top plane with 100 millimeters, and now I have these two planes and they are parallel. I will start a sketch on the top. Set this to 50. And then select plane 1 and start a sketch there. And now I will have some offset here. Set this to 100. And set this point with the origin to be horizontal. And then set a distance between them of 25. Then finish the sketch. And here, as you can see, we have two sketches. What Loft tool does is that it connects these two sketches. So when you select Loft, you have profiles and guide curves. First of all, let's talk about profiles. For profiles, simply select this sketch and then select this one. And here, you will have them connected. Now, this green point here is called control point. You can drag it around and notice how it will change the geometry. For most of the cases, you need them to lie along the same line. To achieve this, hit the space bar and select this face and make sure to drag it all the way here, and do the same with this one. Drag it all the way to the right. Now, hit OK, and here we have this loft created. Now, it's not limited to two sketches. Select loft, then hit the delete button. I still have my sketches, and now select plane 1, then reference geometry, and I have an offset with 100 millimeters once again. Select the new plane, start a sketch, and this time I'll draw another circle here and set this to 50. Then hide this plane, and here, as you can see, I have three sketches. So select loft once again and start here, then here, then here. And as you can see, I have this geometry. Now, let's have this view and drag the control points. Then finish the command. Imagine if you need to create such a geometry using the tools we already learned. That will be really hard. So using this tool, you save a lot of time and you can create complex geometry. I will start with a sketch on the top, and here I'll draw a polygon. Then I'll make this line horizontal. And this is 50. And then select this plane once again. And here, let's draw a circle. Now, once you're done, select Extruded Boss, select this polygon, and then select this circle. And here, as you can see, this control point lies on the same line with this one. This is the first type of loft. Now the second type gives us more control by using what we call guide curves. Let's delete this loft, and here I will select the front plane. I need to hide this one, and let's draw something like this. Basically, it's just an arc, and draw another one here. So the regular loft, we know, connects these sketches. Now I want the loft to take this curve into account. So select loft, and then, as usual, select this sketch and this one, and they were connected. Now if you go to guide curves, you need to select this curve, then hit OK, and you need to select this one, then hit OK. And as you can see, it took into account the shape of this curve. Now to have a better control, you need to create another two curves here. So I will delete this loft, then select the right plane, and let's do the same here. Make sure to snap to the endpoint, otherwise there will be a problem. Now, loft this sketch with this one. For the guide curves, I will select this one, then hit OK, and this one. After that, select this one, and finally, you need to select this one. And here, as you can see, we controlled 4 sides of this loft. If you want to have better control, you can create more planes, and then you can create more curves, and this way you will have better control on the shape. This completes this section. In the next section, we will talk about other 3D tools.